Okay, so today's learning target is that I can solve a system of equations by the substitution method. So we've solved system of equations by graphing, so we know that we're looking for where those two equations have the same point, right? What x and what y will solve both of those equations simultaneously. Okay, so using the substitution method is a process by which you take two things that are equal and you swap them out. So in these first examples, we're just going to practice with substituting. So for a, it tells me that y is equal to 5 and 2x plus 3y is equal to 25. Well, I can't solve for x while there's still a y in this equation, right? In order to get variables and numbers and things solved for, I need to get rid of the multiple variables. Since there's an x and a y in this equation, it can't be solved immediately. So what I'm going to do is try to swap out one of those with something that I already know. Well, in this case, y is also equal to 5. So because these two things are equal, I can exchange them, right? Wherever there's a y, I can replace it with 5. Now keep in mind that 3y is 3 times y. So if I'm replacing y with 5, then it's going to be 3 times 5. Okay, so I've still got the 2x. Okay, and I replace the y with 5 and plug it in. So plug and chug. Evaluate. I've got 2x plus 15 is equal to 25. And now I can take that and solve for x because there's only one variable. That means that I can get it by itself. So the second thing I do, once everything's been evaluated and simplified, I can solve for what I need to solve for. Okay, so I'm going to subtract the 15 from both sides. I get 2x is equal to 10, and then divide both sides by 2. Alright, so pause the video real quick and try the second one and see what you get.
We are still in need of a sub for periods 4 through 8. Please call 21002 if you're interested. Thank you.
Okay, so what you should have done for the second one is I plugged in 7 for y. Okay, so the y is over here. I can replace it with 7. So you get 3 times 7 is equal to negative 2x minus 7. Simplify. 3 times 7 is 21. So negative 2x minus 7. And then I want to solve for x. I'm going to add 7 to both sides. I get 28 is equal to negative 2x. And then divide both by negative 2. So x is equal to negative 14. Okay, so one more example. Got y is equal to negative 3, and I've got negative 4y plus 3x is equal to 5. Okay, so I need to get rid of one of these variables. Well, since I know that y is equal to negative 3, I can get rid of that by replacing y with negative 3. Okay, so we got negative 4 times negative 3 is 12, plus 3x is equal to 5. I'm going to subtract 12 from both sides. Okay, so I get 3x is equal to negative 7, and divide by 3. So x is equal to negative 7 over 3. Okay. So we're going to use the same process to solve systems of two equations in two variables, except for the first thing that I need to do is get a variable by itself. So solve one equation for a variable. Okay, So I don't need to solve both of them for a variable, although that wouldn't hurt, but I'm going to solve at least one. So I'm going to pick the easiest one to solve for a variable. I'm looking at this one, and I see 2x minus 3y is equal to 12. Well, that's going to take a lot of steps to solve for a variable. Not too easy, right? I've got to get rid of one of the variables, so either add or subtract, and then I'm going to divide by something. That might end in fractions. What I'm looking for is a variable that's all by itself. So in this first problem, I've got x and y that are all by themselves, right? And just to prove a point, I'm going to solve for x. Like, it doesn't matter which one I solve for, x or y. It's got to be the easiest, right? X is by itself, so I'm going to solve for that one. Okay, so to get x by itself, I'm going to get rid of y. So remember, lock up the x and then get rid of anything else that's there. So I got to get rid of y. So to do that, I'm going to subtract y. And so what I get is x equals negative y plus 1. All right, so the second step is to substitute that new equation, or substitute that value into the second equation. So I have x equals negative y plus 1. That means that wherever there's an x, I can replace it with negative y plus 1. Okay, so I'm going to ignore this top equation, right? I've already used it. I've changed its form. It's now x equals negative y plus 1. So in order to solve the system, I have to use the second equation. So I have to substitute into the second. Okay, and for that, I'm going to use a different color. Okay, so I've got this 2x minus 3y equals 12. Okay, so this x is equal to negative y plus 1, so I can replace x with all of that, right? I need to remember that x is being multiplied, so if you need to, put parentheses around it and fill in the parentheses, right? I am replacing x with this whole thing, and this whole thing is being multiplied by 2, right? Because if I take that 2 and move it up here, I've got to multiply this side by 2, right? So when I replace it, it's going to look like this. 2 times negative y plus 1 minus 3y is equal to 12. The third step is simplify and solve. Okay, so once I've got it plugged in, all I got to do is simplify. So get rid of parentheses using distributed property. So I've got 2 times negative y is negative 2y. 2 times 1 is positive 2. And then negative 3y. All right. So simplify as much as you can. Negative 2y minus 3y is like terms. So I'm going to combine those. So I've got negative 5y plus 2. Okay. So negative 5y plus 2 is equal to 12. So now I can solve this equation for y. Y is the variable that I need to get by itself. Okay. So I'm going to subtract 2, get negative 5y equals 10. And I'm going to come up here. So now that negative 5y is equal to 10.
I'm sorry, my mistake.
Okay, and then finish the problem solving for y. Okay, so I'm going to divide both sides by negative 5. So y is equal to negative 2. Okay, plug that back in and solve for x. Oops. So the easiest way is to plug into step 1. Okay, so plug into step 1 and solve for the last variable. So I've got y is equal to negative 2. Step 1 tells me that x is equal to negative y plus 1. So I'm going to take that and plug it in. Okay, so I'm going to take that negative 2 and plug it in for y. So x is equal to negative of negative 2 plus 1. So x is equal to 2 plus 1, so x is equal to 3. Now, when we write this solution to a system, it was an ordered pair when we solve by graphing. So it has to be an ordered pair when I solve by systems, or solve by substitution as well. So my solution, remember, is an xy solution. So x is 3 and y is negative 2. Okay, so please think this over, come back tomorrow, be ready to practice and learn. Have a nice night.